Hello and welcome to my channel. In this video I will compare the performance of few frameworks: Flask with synchronous ElasticSearch client, FastAPI with asynchronous ElasticSearch client, and I will briefly show ElasticSearch client written in Rust with two frameworks, Actix and Axum. I hope you will enjoy on this video. I want to mention that the ElasticSearch instance is deployed on the official ElasticSearch cloud and it represents a real production environment. Okay, let's start first with the Flask implementation, and before to run the Flask, let's start locust load test. And let's load it here. Okay. Let's start one more process. And let's start with Unicorn. And I will start 8 workers because that's the number of my CPU cores. And Actix and Axum by default starts processes equal to the number of cores. For that I will use for Flask and for FastAPI 8 workers. Okay, I started them. Let's briefly show the implementation. So here you can see standard Flask with Flask RESTful application, and here is the more interesting part. Let me make it like this visible. You can see I'm using synchronous ElasticSearch client and I'm connecting to the cloud ID. So let me be more specific. I deployed ElasticSearch instance on the official cloud of ElasticSearch and I connected to this ElasticSearch instance. And here briefly to show what information I upload. This is some e-commerce information, some dataset with almost 3000 entities, and I'm searching by product ID and here by title, product title. Okay, they are already loaded in the ElasticSearch. Okay, and here are the resources, Flask RESTful resource, and here we have get with the same, I used the same query, ElasticSearch queries in the all code examples. And let's open now locust. I will use 200 users and ramp up 10 users per second, and let's start that. And as you can see, we have big waiting time. The average milliseconds for a request is now more than 1 second. You can see. And from my perspective, that it's too much. I will wait to have more than 2000 requests, so we will be able to compare the results from the older frameworks. Okay, let's stop that. You can see almost 2 seconds for response time with Unicorn and 8 workers for Flask application. Okay, let me close that and open new one. FastAPI, and I will open the FastAPI implementation. I will load the virtual environment and I will start again 8 Unicorn workers. And let me show the implementation, but first let me start the test. Until I'm showing the code, and here I have the FastAPI implementation. First I want to point that here I'm using the async Elasticsearch client. That is the difference, and everywhere in all methods again I'm using the async await, asynchronous programming, and here in the router you can see I'm awaiting again everywhere I'm using the asynchronous programming. Okay, and let's see what is going on. You can see the average response time is not so big, almost 200 milliseconds, 10 times faster than the Flask with synchronous programming. You can see the difference, a really big difference. And I will stop since we have already more than 2000 requests, and you can see 10 times faster. That's because of the asynchronous programming and the event loop. Okay, let's stop that and stop this for a moment too. I will close Python frameworks and I will start to show Rust frameworks. I will start with Actix. I will build the release, but I already built that release and I will start it. And here is the code. Let me briefly show it. Here I'm starting one Actix server. You can see I'm using the code for the Elasticsearch client, which I've showed in one of my Elasticsearch series videos. And here I'm using only the asynchronous programming, since that's the implementation of the Elasticsearch crate. Okay, I will not deep dive. I will upload this to a GitHub repo, and as I mentioned, I have a tutorial how to create all of this. Let's go to locust. Here I want to make one change in the locust code. I want to listen 818, and let's start again locust and return here. Let me open new tab. 210. Okay. And you can see here also we have a small response time. Let's wait a little bit. And you can see it's almost comparable with the FastAPI. So here the key point again is the event loop and the asynchronous programming. So here I want to point that we are dependable from the networking between our host and Elasticsearch host. So this is the limitation. If we are using Python on Rust, it's the same. That's my opinion, and I will show one more framework, Rust framework, Axum. There will be no difference, but I just wanted to show one more than one Rust frameworks. Okay, here I have to tweak again the port. Let's open that on a new tab. And the results will be similar, and by my opinion, I will choose Python with FastAPI for Elasticsearch interactions, since Python is easy, really versatile, really beginner friendly, and the implementation is not so complicated. You can see similar result with Axum also. You can see. So until we are waiting, or let me show you briefly the locus code. Here I am just loading that data frame, taking the product IDs and the words which doesn't contain that symbol because it can make some problems. Okay, I will stop. You can see similar results. And here I'm creating the tasks and I'm taking random choice from that. Here we have a tuple and here we have list of IDs. Tuple with product title word. Okay, and here are the final results. Here is the Flask application, the slowest one because it doesn't use event loop. Here is the FastAPI, you can see 10 times difference. Here is Actix-web and Axum. Okay, thank you for the attention.